We should be live. As you're joining in, say hello in the chat. I know we're a minute early. Just wanted to get the stream started as people are joining. And I'll probably share these a few times. But if you do want to start poking around at the code, I'll share this in the chat. Link should also be in the description as well. So if you are coming back watching the recording, everything should be in the description if you want to follow along. So I know some people like to actually follow along, run the code. Some people just like to watch. Either way is fine, but I will run this in a way where hopefully if you want to, you'll actually be able to run all the commands. But we can actually even do it from a Colab notebook. If you signed up and RCP'd on Luma, you've been given access to like a remote cluster that we'll connect to. So you'll be able to run the workflows there and deploy the model and deploy kind of a UI application that we'll make around it. But you can also run all this locally, just a couple ways actually. Locally, all with open source. So I'm going to show you stuff today. Again, if you want to follow along in the Colab, just makes it easier if you're connected to the remote cluster. That's going to be in a Union AI cluster. We can talk a little bit about that, but I'll wait for more people to join in. And again, as you're joining in, feel free to say hello in the chat and ask questions there as we go. I'll try to answer them as we go. If there's a lot, I might wait a little bit before we finish kind of some of the slides, get in the code, but I'll be keeping an eye on the chat. Just waiting for more people to join in. And let me just make sure that I'm live. Looks like I am. It's always fun to hear from people if you're here, that you can see me. Let me know. Also, I know it's the week right after a long weekend. So often when that happens, usually there's a little bit less of people that end up attending just because you're kind of in crunch mode catching up. Someone said, yes, sir. I assume that's to being able to hear me. Cool. Thank you for letting me know. I'm just going to wait another minute or two as people are joining in. Because I know we had quite a few people RCP. Again, it might be a lower ratio of attending versus RCP just because it's the holiday week, but starting to see some people trickle in now. So I'm going to wait another minute or two before we get going. And I just have a few slides I'm going to go through at the beginning that are really just like set up for the kind of topics and tools that we're going to use today. Again, if you want to get started, there is this direct code repo that has instructions in the README. If you want to start running things as easily as possible, kind of during the workshop, like you don't want to do any local setup with like a Python environment and install things that way, which is pretty easy to do. But if you don't want to do that, there is a link in there that has this open in Colab button. You can click that and it'll open up a Colab that I will run through, and I'll walk through this with you. But this contains all the commands that we're going to run and kind of a setup for Colab. But all the code that we're running lives in this repo. And so the main thing you might want to look at is like this workflow.py, which again, I'll walk through this a little bit later. But if you want to start poking around, you're more than welcome to already. So I'm going to do slides, and then people said they kind of like seeing the thing that we're going to build in the platform, which is not too many tasks. So that should be pretty quick, but I'll just kind of, again, go through what we're going to build. And then we'll go through the code, and I'll answer questions as people want. But yeah, as people are joining in still, this is where we're going to build. We're going to build a training pipeline that is going to train a machine learning model. We'll use XGBoost today. It's also going to use a feature store, which I'll talk more about feature stores in a little bit. We're going to use one called Feast that's open source. And then we're going to train a model to predict fraud. And then you can see there's a little report on the model that we're going to train. And then we're going to deploy that in an app. So we'll actually deploy the model as like a fast API endpoint. And then we'll be able to call that model from like curl, but also we'll deploy this kind of little Gradio application. It might take a minute here to do the first prediction because I think my model spun down and spinning back up. Once it's back up, the prediction should be incredibly fast. So did a prediction there. You can edit parameters like this is the hour of the night or hour of the day. And as you can see, like that can have a big impact on if we're predicting fraud or not. And again, we'll look at all the code for this in a little bit too. But just to give you an idea what we're going to build, a whole basically pipeline that you can rerun with different parameters, fine tune your model. We're going to use a feature store to serve those features to the training part and then also to the actual deployed part. So if you haven't used a feature store before, I'll talk a little bit about it. But in general, it's one of the big impacts that it can have is that it helps reduce kind of the training and serving skew of having mismatched patterns and data between like your served model in this case, because we're using those features as part of the prediction part and then during the training phase as well. Has anyone used a feature store before? Actually, that'd be kind of a fun question. And if you have, which one have you used? So I know there's quite a few. Feast is the one I've used the most, which is an open source, pretty popular one. They also have like an online platform that you can pay to host the features there. Tecton is another one that someone acquired them somewhat recently. I forget who acquired them, or a couple of years ago now. And then there's another popular one. There's definitely several, and a lot of clouds will have their own. I think like Vertex AI has their own, AWS has their own. There's another big one that's like an open source one. I'm blanking on the name right now, but curious if anyone's used one before. All right, so I'll go through these slides hopefully pretty quickly here. But again, if you have questions, let me know. If you want to, again, go ahead and start poking around at the code or run the collab or anything that we're going to build, feel free to open up this GitHub, start playing around with it as we go. I know I like to do that sometimes, like if I'm at a workshop. And then if you want to join a Slack group and have more permanent discussions or ask me questions there, you can join the Flyte Slack group. So Flyte is our open source AI orchestration tool that we're also using today. And I'll talk a little bit about that later and you'll see it in action. But that's a pretty just active machine learning group in general. So if you want to say hello, maybe do a more permanent introduction there, share what news has come out, etc., that's a fun place to do it. So, all right. Oops, and I have a misspelling of fraud, I think there, right? But this is a fraud detection with Feast, Flyte, and XGBoost. And I kind of went through, if you were here before, we're going to build a pipeline and serve the model and have a little UI that can interact with the model if we want as well. Just a tiny bit about me. And as I'm telling you about me, you should tell me about you in the chat. So my name is Sage Elliott. I work at Union, and we build AI orchestration platform for like training models, serving agents. A lot of people are using it as like a runtime now to run agents in reliably. You get like tracing, scalability, so everything can run in containers. It spins it up. It manages the compute. You'll kind of see this in action with the open source too, called Flyte, Flyt. It came out of Lyft originally, and that's why it's spelled that way. But it makes it really, really easy for you as like an AI engineer to get access to the infrastructure and reliability piece of like Kubernetes without feeling like you're developing with Kubernetes. I'm in Seattle, so that's where I'm streaming from right now. Some people might know me from also running AI book club. We just actually did a meeting on that yesterday on diffusion models, which was pretty cool. And previously, I've done a lot of work in computer vision, ML monitoring, evaluation, ML ops. And then I even had kind of a previous career doing like hardware and hardware reliability engineering and some robotics as well. If you want to stay connected, you can find me on LinkedIn or again, join the Slack channel if you want to also talk to me there. Again, let me know in the chat. Only Kevin has talked at all so far, but I see quite a few more people here. Let me know a little bit about yourself, or let other attendees know about yourself. It's really fun kind of seeing where people are tuning in from, but also like what you're working on or what you're learning. I think it's really cool to see. Makes it more fun for me, hopefully more fun for the attendees as well. And then, so today we're building a fraud detection system, and fraud is interesting because it like when you're in production, you usually want to do this very fast, and you want to use like features for a whole bunch of different people. And like you can imagine, right? You've probably had like a fraud thing get detected on your credit card at some point. Maybe you're spending hundreds of dollars somewhere, and maybe they thought it was an unusual pattern, and then they send you a text or a notification on your app saying, did you actually do this? And you have to say yes or no. And we're going to talk a little bit about some ways how they can process and do that in such a fast time. And that's why we're going to use a feature store today to bring in those features. And then we're going to use a pretty lightweight model that runs incredibly fast called XGBoost that you might have used before if you've done more traditional machine learning. But a big part of this too is that training and serving pipelines can drift apart. So producing features at train time that don't exist at inference, or they just look a little bit different. And I'll talk about that in the next slide a little bit more on the feature store point. But it can be a big problem when you're doing something like this. And you need kind of this very quick kind of point in time correctness to bring in those features, like previous features, to this new data that's coming in. So feature reuse, which really just the next slide goes into more of that, which is, again, we're using Feast for the feature store, which is open source. And I actually forgot to put the link in the slide here, but let me link you to their site and you can check out their open source here as well. So Feast is an open source feature store that sits between kind of your data sources, your models, and then serving those same features at usually training and inference is kind of why people like using feature stores. And that's where we're using it today. And if you've built like complex pipelines or building features that need to be shared between teams, you might have run into issues where a feature store can be useful. If you've done more just kind of smaller personal projects, maybe you haven't needed a feature store. And so you might be like, why do I need a separate thing for this? This is where kind of the term is like training, serving, skew is a pretty common term for this, where during training time, we're defining features for our model. And in this case, they are pulled from this credit card fraud detection data set. And actually, if I pull up the code, we can look at some of these features that might help to illustrate it. Like we're defining a mean amount, distance from home, hour of the day. So a whole bunch of different things that would go into things for like fraud detection in today's use case. And if you have a separate person, which is pretty common in teams, like doing the training piece versus the serving piece, and you don't have the same person defining those like doing the feature engineering, but for both of those, this is where like kind of that skew can happen, where you say, someone says, okay, like this is the definition of a week, or they say like make a feature for a week, and someone does that from Monday to Sunday, the other person does that from Sunday to Saturday, or they do like a rolling 7-day period instead of having to find days. And that can really throw off, obviously, if you trained in like different features and then you serve it with the other definition of it, that can really, really throw off your model. So feature store is basically like a source of truth of how these features are engineered, and then you can bring them into both the training and serving like we're going to see today. And again, it makes more sense like if this is like a bigger team and you might have those communication issues or different definitions of things, and you don't have like a single source of truth. That's why you want something like a feature store. So you can materialize it from data in your offline stores and then have this served in different ways. Like we're going to serve it today just directly in our kind of Flyte app. But you could also serve this in like a hosted version. Like I think Feast has one, whatever their parent company is, if it's not just called Feast. And then like Tecton, these were other ones where you could have these like source of truths to pull those features down in for wherever your team needs them. And that could be training across different people, or again, the common one is the training, serving, skew like we're going to see today. And then we're going to use the XGBoost model, which you might be familiar with, like if you've done more traditional machine learning. It works really strong on tabular data, and it's what a lot of fraud features or a lot of fraud detection models, I believe, still use under the hood for their detection. They're going to be trained on features that we're going to see today and then used in real time. They're also going to run really, really fast, which is nice. So you're not using some really a model that's going to take a long time to run. Like we'll actually see this isn't even running on a GPU. And again, once the model spins up, the first time we run it, it does take a minute because it has to scale up. But now it's up. We can see it runs in like very, very fast to give us any prediction back. Because you want to have this really fast, right? Like getting your credit card with a weird charge, and then you want to text that person probably as fast as possible. And XGBoost works really good for this. You can try other models as well. And if you're familiar with like decision trees, XGBoost is kind of a form of that, a little bit different than random forest, where it uses what's the other term of is it bagging, where you have like parallel trees and then you have the ensemble where you're seeing kind of the average of the ensemble predictions. And boosting, I believe, is the similar to kind of, you have those different parallel trees, but some can be in sequence, so they kind of build upon each other, and it works really good for uh, interesting like tabular data that you might see in like fraud prediction. And then for the orchestration layer, we're going to see this in action. We're going to use Flyte. If you RCP'd on Luma and you're going to follow along, I gave you access to a temporary cluster that's hosted on Union. But you can do all the things that we're going to do today just directly in the open source as well. But you can deploy this on cloud or on-prem, and this gives you a declarative infrastructure. So instead of you writing Docker files or configs to get access to the CPUs or GPUs that you need for your workflows, you just define an environment like this directly in your Python code. And we'll see this in our code here in a minute when we go into it. But I'm just giving a name. I'm saying what type of image I want. So this just starts from a Debian base image, and then we're going to pass in requirements.txt in this example, but there's different ways to pass in requirements, and you can add things like apt-get or specific CUDA versions. And then we're requesting resources from our cluster. So here I'm saying I want 4 CPUs, I want 24 gigabytes of memory, and I want a GPU. And you can assign specific types of GPUs to this as well. If you have like A100s or T4s in your cluster, you can define that here. So you as like an AI engineer, you just have to write this now, and you get access to something that's going to request those resources and build that container for you. And it's Kubernetes under the hood, but it just doesn't. It just feels so easy to work with this like Python SDK, which is nice. Once you define that environment, then you write Python functions kind of like you normally would, and they can be async. And you just basically add a decorator around them. And then when you call this task, that's what we call it when it's wrapped, then that task is going to run in this environment that you requested. And it's going to handle like the image building and everything again for you automatically. So you don't really have to deal with that, which is very, very nice. You also get versioning out of the box. So if you go back to runs in this case, you see that I have several versions in here, and I can go back to a previous one. I could look at what the hyperparameters were and adjust it, or I can even pull out the artifacts, which in this case would be like a model. And so when I'm deploying this model, I can keep adjusting hyperparameters, go back and compare them, and then pull in the specific one that I think is going to do better for my use case. So every time you do a run, you get this automatic versioning of all the code as well, and all the hyperparameters and all the artifacts. So it's really just a whole snapshot of your entire pipeline, which is really useful for, I think, a team of like any size, but also some industries. This is really important for auditing. Like if you're doing healthcare, I think also quite a bit in finance. Like you need to basically have a trace back to being like, what was the exact snapshot of my data at this time, and why is the model behaving the way that it behaved? I can have this kind of compliant a log that I can come back to, which is really nice. But this is also just powerful for, again, any team doing experimentation. And also do caching, just passing in the decorator as well, where if you rerun that workflow, it's not going to rerun the work that you've already done if you just want to use that cached output, which is nice. And you get that UI we kind of saw. It's built on Kubernetes, so it can scale up. Like a lot of people find Flyte, especially in V1, when they had scaling issues. So like a lot of self-driving car companies use Flyte to spin up their training pipelines when they need to orchestrate a ton of compute, and then again save all those artifacts and share them across teams. In V2, it's just all pure Python now, so it's really nice. There's no DSL. You can just write a task that calls other tasks and do like loops and if statements, which is really powerful. So you can use it for agents now as well. We'll see some of that in action in our pipeline. So again, if you want to follow along, you can go here. And is everybody ready who wants to follow along to train a pipeline and then serve the model? And I think what I'm going to do, so I will walk through code in my IDE here. But what I'm going to do is first get everyone started, I think, by running the notebook. So if you open up that repo I shared and you hit this open in Colab, you'll get this link. I'll share this. Oh, someone said they thought they registered and then they might not have got populated. If you want, you can message me on Slack and I can add you later. It's a little bit of a manual process right now because it's not a serverless product. Like, this is what people use in their on-prem and on cloud. So we have like a temporary cluster. But if you message me later and you do want to run stuff in there, I can add you to the cluster at least for the rest of the day, or probably even tomorrow or a couple days. But I probably won't add you just during the workshop here because it takes me a minute. But yeah, I apologize. That's the best way I can do right now is get the RCP list and then add it in on Luma. But you can also run this code locally, which I can show a little bit later too. I'll go through the collab and then I can show a couple different ways that you could do this locally too. So if you do want to do just a tiny bit of setup, it's not that much. You could do that as well. A lot of it's in the README, but I'll go through the collab for people who want to follow along if that works for everyone. So open up this collab. If you want, you can also save a copy in Drive, and you can make edits to this if you want. You don't really need to, though. Or you shouldn't need to if the demo gods are with me today. So we're go ahead and run this first code cell. Google Colab's just Google's way of hosting like a Jupyter notebook, and they give you a whole kind of runtime. That was just a little warning saying this wasn't authored by Google. Do you trust it? You can hit yes. And then this is going to get cloned that workshop repo inside their instance where this is hosted. And then it's going to change directory into this fraud detection one, which is where the example lives. And it's going to uv pip install this requirements.txt. We also have to add, just in Colab here, a keyrings alt. So this is going to allow us to save the authorization credentials in kind of the notebook environment. If you don't do this, it'll ask you to like reauth every time you try to do something. So just going to make it more convenient here. And then I didn't make this up. This is what you call the terminal when you want less fancy output, is dumb, which I feel like is really sad for the terminal. I think the terminal is great, but I have to call it dumb here. And we're just setting this environment because Colab tries to do some fancy stuff with the output sometimes, and it messes with the Flyte output. So there's a little couple of gotchas with this. Like if you click on a link, it might be broken, but we have to do this to get like the authentication and stuff to work correctly in Colab. So again, those are just specific Colab things. But if you're setting this up locally and you already have UV installed, all you have to do is really actually just git clone the workshop, change directory into it, and then uv pip install requirements.txt locally in your Python environment, and you should be good to go. Then we want to connect to the Flyte cluster. So in this case, you can go ahead and run what's already here. This is going to connect to the instance that we're using for the workshop today that I added the people who are RCP on Luma. So if you didn't get on there before I started the workshop, you might not have access to this. Again, you can run locally, or you can also set up Flyte to actually run a whole thing called dev box locally as well, which I can also show off a little bit later. And someone asked for the Slack group link again. Let me pull that up and I'll share it again. Basically, this just adds a config file that tells us where we're going to run stuff when we want to do it remote now, and different things like authentication type, builder. This is going to build our container images remotely, and so we don't even do that locally with Docker at all. And then it'll, if that container doesn't exist when we run a command, we'll build it and then run our task in there. By the way, in Colab as well, if you are running in here, you can go to this little folder icon. You can see this is our workshop repo, tutorials, and I can scroll down to this fraud detection one, and this is all the code. So if you did want to pop into any of the files here, you can double click them and open them up this way. I'm just going to go back and forth through my IDE because I think it's a little bit easier and maybe looks a little bit better. But if you want to explore the code this way, you can do that as well. You can actually even edit stuff here and then hit save, and then it'll pull from this. So we set up our config, and then we're going to run our pipeline. Our pipeline looks like this, so it's going to do fraud detection. Again, I'll walk through all the code. I'm just going to have us run the pipeline, and then I'm going to go through the code. People have said they like that kind of format better, I think, versus going through the code and then running the pipeline. Maybe seeing what the pipeline does and then go through the code, I think, gives you a better picture. So we're going to prepare the data. This downloads a data set and engineers the features. And this data set is this Kaggle credit card fraud data set. So if you were actually doing this in production, you'd hopefully want your own data or add your own data to this. And then we're going to materialize those features. So we're going to use Feast, that feature store, and bring over the features that we know that we're going to use between serving in production for our actual fraud detection piece and what's going to be used in the training piece. And then we'll materialize that and we can pass that around to this training model task, which is the next one in the pipeline, where we pull in those features, train our XG boost model, and then we'll serve both the model or we'll be able to save the model and the feature store as artifacts that we can then pull out of this workflow and then serve it in like an API endpoint and then actually interact with it. So if you run this command here, this is going to run this workflow.py. Again, you can click around it here. I'll go through this in a minute though. You're going to get this sign in link. You can go ahead and click on that. Click next here. And then if it's your first time running, you might have to click a few other buttons to kind of authenticate your account with your email address. Again, if you signed up for Luma, you should be added to the cluster and have access to it. If not, you might not be able to run this right now. If it was your first time running this, it might take a minute because it's actually going to have to build that image. And it'll say like building image. But for me, it's already has a run going. And this is one of those things where when I said the terminal is equal to dumb, it kind of messes with a little bit of the output URLs. Like this is broken here. You can copy the whole thing though, paste it in and fix it this way. Or if you have access actually, and you just want to even look at my workflows, you could go there because you should have the shared project. Or if you just want to look at all the projects, which in your case might just be one, unless you're here for another workshop, you can go to this URL. So you can create different projects, obviously, for different things you're working in here. And then I have this one, this workshop feast, which is what I'm currently running in. And then I can see my pipeline is currently running. And I had run this before. So the prepared data one is actually already cached. So it's saying it read from cache. So that's why it says 0 seconds here. And then because I didn't run anything recently in here, and this is just like a pretty small demo cluster. It's just waiting for some compute to be provisioned for us to use. And then we'll come back and look at this in a second. As that's running, I can go ahead and go through the code, I think, for it. So this is us running that workflow.py. First, I'll look at this config. Let me zoom in. Let me know if this is good enough for everybody. I can probably close that out a little bit. So you could put this directly in the workflow.py too. I tend to kind of break mine out into this config.py, which is where I create my environments. And the reason is if I'm doing more complex workflows and I have multiple environments, like a lot of times I do deep learning stuff or something with like a small language model, and I want to have multiple environments with a GPU or different resources in there. In this case, we just have one because it's a pretty lightweight model today that we're using. In fact, you could run this probably just locally on your machine pretty good, even though then you'll have to serve it for today because our data set is like somewhat smallish for our demo. But here again, we saw this in the slides, but I'm giving it a name. I'm giving it a base image. This is Debian base. And then I will probably change this later. Actually, I usually just read it from our requirements.txt. It just makes it easier to sync between the local environment and the remote environment. So you can iterate locally and then say run remote, and then it'll kick off that big remote job. But you can also specify each individual package with pip packages instead of with requirements.txt. Again, you could add other things here like specific CUDA versions. You could apt-get in specific packages, etc. And then I'm declaring what resources I want this to run on when I run it on remote, which is in this case just 2 CPUs and just 4 gigabytes of memory. But you would increase this a lot if you had, like a massive data set or something like that. But this is useful again if you're doing deep learning. You might have an environment that looks like this for like downloading the data set, maybe doing pre-processing on it, and then during the training phase, you want to set those resources to be bigger for like different GPUs, but then you're not wasting the GPU resources when you don't need them, like on that downloading data part. And then if I go into the workflow.py, is where we define those 3 tasks that we are running. Where'd my tab go? Sorry. So they all ran now. We have this prepare data task. We have this materialize features. And then we have this train model. And all these have a report that you can kind of go see like what's going on here. We trained our model in this report tab, which is, again, a really nice thing. And this is all version 2 with your run. So you can go see, in this case, like the model performance. You could look at training data. You can log whatever you want. Here's just HTML or Markdown that you can embed in to make it really valuable to go see like what was going on. in your training runs in this case. I've even used reports actually for cool things like doing reinforcement environments with like robotics, and then I want to bring in some of those frames to see like how the robot was behaving directly in a report. It's a really nifty thing to do. So when we go back in the code, we go to the workflow.py with some helper things here that are just extracting or predefining features, I should say, that is in our data set. Then we have our first task, which is downloading a data set and engineering those features. So we're just going to add that environment decorator that we kind of talked about. We're also going to say we want the report to equal to true. So the HTML report is going to render. Because it's cache, you might not see it here. Let me see, actually. This is going to load in. I think because it's a previously run one, it might not load here. I have to go back to the original task to see it. But you'll see a report like this if it's the first time running there. And then we're saying cache is equal to true, and that's why when we reran the workflow, it didn't show up. And then we define our Python function, and we're also forced to give types for the Flyte workflows, which is also kind of nice. It kind of makes you define what is going on in that workflow, and then we hand this off to other people. They can see exactly what the input types and outputs should be. And then also it's going to yell at you kind of if you pass in wrong types, right? Which is kind of nice. So we're saying this is going to equal to a Flyte directory. There's something called Flyte file and Flyte directory. If you're not familiar with working with containers, by default, it's going to spin up an instance basically to do this task in that we've defined. And then it's going to spin it down. And then when it spins down, if you saved a file, for example, that doesn't exist anymore, right? So how do you reference it to another task? Like you download a data set. Where does that data set live now? You want to pass it over to the next task. And so you can output something called a Flyte file and Flyte directory. When you just output that, which we'll see down at the bottom, it returns it as that type. It basically just saves that to wherever your object store is. So when you set up Flyte or Union, you define like, this is my S3 bucket where these things are going to live. Or if you're running Flyte DevBox locally, it'll be a local version of that. But now when you do that, it kind of just saves that file to that object store. And you can reference it again. And it kind of behaves like if you pass this off to another task, it now behaves as if that file is already kind of there. And it's just really nice. It makes it working between containers with different files really, really easily. So we're importing Kaggle Hug. That's where the data set is. We're just going to download this credit card fraud detection one. We're going to get that CSV, going to load into pandas. And then we're just getting like a training sample size from it. So we're not using the entire training data set for the workshop because I think it would take probably too long. And then we're extracting features like timestamps. We're basically just doing a whole bunch of stuff like when we defined some of the features that we wanted above. We're just doing the feature engineering where we're saying, date of birth is equal to this. Just doing that type of thing across all the features inside of that data set. So do that quite a bit. I won't go through every single one. And then again, we're just writing a little report, and then we're returning the directory that we talked about. So it downloads the data set, it extracts features from it, saves in that format that we want, and then returns it that we can use, returns it as a file that we can use into the next task, which is this materialized features, which is going to read in those features. So we give it a input. We can see the data type is that Flyte directory, and the output is going to be another Flyte directory. But this input is going to be downloaded, and then we're going to create a feast formatted file out of that data. So if you scroll down, these are actually all the ones that we want to share across the training and serving piece of it versus just the training piece. And then we're just going to basically do similar things, getting our fields, writing a report. That's what the HTML is. We get this. It shows these are the features that we want to have between serving and training. And then we're returning it as a Flyte directory. And this is going to be the feast file now that we can use in our next task, which is the training, the XG boost. And then also we can now reference this file out and pull it into our serving piece, which we'll see a little bit later too, once we have our model trained. So let's take some other inputs like Flyte directory, feast directory. Now that we have both, or sorry, the data directory, feast directory. Now that we have both of those from our previous task. Hyperparameters for training our XGBoost model. So again, you can change these out here if you wanted to, or when you call it, like if you are running this, you can also pass in the parameters this way. And again, every time you change these parameters, you'll get a version run that you can come back to and see how that model performed. So obviously, if you've done machine learning before, very common to change out your hyperparameters and do some experimentation to see how your model's running. So we download that data. We are pulling in the features from the feature store, transferring them to a data frame for training here. A lot of just the kind of, again, changing the features over that we want to use for our model. And then we are initializing our XGBoost classifier model with those hyperparameters that we pass in. Call model.fit on the data that we created. We're going to extract some metrics, and this is what gets put here. So like the area under curve. This is the amount of training samples and test samples that we used here. We can see our recall was 86%. And then this is our confusion matrix. So this is how many of these were legit transactions, and it predicted most of them were right. It got a few wrong. It predicted some were fraud. But again, sometimes you want this, like in fraud detection, you would want a higher recall usually over accuracy. So like the good example I like to use for that, if you haven't thought about it in a while, is if you are doing something like a gun detection computer vision model in some sort of X-ray thing in an airport, and say 99.9% of people never have a gun, and so your model just always predicts there's never a gun. Well, the accuracy would be 99.9%, or the accuracy would be like 100% or 99.9%, right? So you'd rather have it misdetect stuff sometimes, and then you double check it, and you say, "Yep, there's no gun there," and then so it has a higher recall in there. And we also pull out from XGBoost, and there's different ways to do this for different models. XGBoost has one built in where you can pull out feature importance. So you can see these are the features that have basically the biggest impact on detecting fraud or not. Is amount. That makes sense. If you're spending like thousands of dollars when people usually don't spend that much, that makes a lot of sense. Hours, there's probably different times where people usually spend money. If you're spending money at 3 a.m., or like you usually don't, and you get a transaction at 3 a.m. for $1,000, and it's on a specific type too. Like we have, was it on merch? Was it on a physical point of sale? Was it online? That can then trigger fraud. So going back to the code, train our model, we build our report, log it, we build the little HTML report. There's also a report helper.py, which has some of the extra HTML for it. We get our feature importance. This is, again, built into XGBoost. If you're using a different type of model that doesn't have a built-in thing for feature importance, you can also use something like SHAP values to try to pull that out. And that's our training piece. And then the orchestration is we're just kind of tying all these things together. So we have another task. We're calling this fraud detection pipeline. And then we're tying all those tasks that we predefined and flowing that data through them. And like I mentioned in Flyte v2, if you had looked at use v1 before, you used to have this workflow decorator. Now everything's just a task decorator. And again, now there is no DSL. So you can use like Python if statements, loops, anything you want to here. Again, making it really good for like agent applications, but also just making it easier to build like complex workflows no matter what you're doing. So we're defining, again, this HTML is for the report that shows up here, which gives us some next steps once this is done. But outside of the report thing, we can see that we're calling that prepare data task that we defined before. And then we're calling that materialize feature task that we defined and passing in the data directory that gets outputted from that previous task. And then we're calling train model, passing in, again, those two things that we just pulled out there, the feast directory, the data directory, and then passing in hyperparameters that get called when we call the model or call the pipeline. And then the actual pipeline itself outputs a model and a feast directory. So then we can just look at this pipeline easily from our app, which we'll see next. And then I'll just pull out these two artifacts very easily. So mine ran here. Is anyone following along? I guess I could probably see if anyone else is running things. No one's running anything yet. Everyone's just watching, which is fine. But if you do want to run, again, you should be able to run these commands in the Colab. Let me know if you had issues too. Sometimes there's some issue of onboarding. I know if you did an RCP, like I was saying, you might not have access to it. But if you swear that you did and you're not, definitely let me know as well. Sometimes maybe I've done something stupid somewhere. So just let me know. So now that we have our model that's trained and our feature store, we can run this Flyte app .py serving environment, and we'll take a look at the code here in a second for this. But what this is doing is basically taking that model and feature store and then building a endpoint for us that we can then query and get predictions back. So if I go to this apps tab, this is where you can host things like models or full apps, which will host a UI as well that we'll take a look at. We can see this is deploying because I just ran it. Maybe I shouldn't have actually run it. It should deploy pretty fast. So we'll wait a second here. I'm going to drink some water. The model's not too big, so should spin up pretty quickly. And maybe I shouldn't have actually run the deploy since we're live and I just want to show it. My mistake here. Should be pretty quick though. While that's going, I'll also show. So we just ran this default one. By default, this is going to look at the latest run. So it'll go look at the run name that I gave it, the fraud detection pipeline. It's going to pull in this latest one here. But if I want to roll back to one of these other specific versions, because let's say I evaluated it, I was doing hyperparameter tuning, I can look at the report and I can see that one of them runs better than the other. I can take this specific run ID, which is this hash here, and then I could pass it in to the Flyte deploy piece in this case as a environment variable. There's different ways of doing this. I have it right now set as an environment variable. So then if I run it, if I uncommented this and ran this one, it would pull in the artifacts from this specific run, not the latest one. So again, it makes it really easy to basically do that artifact management between all those different version runs that you have. Should be deployed. All right, so it's deployed now. Again, we'll take a look at the code here in a second for that. But it should be deployed, and I should be able to interact with it with curl. And so we can see that I I called the URL, which if we go back to the apps tab, you can see this is the URL where that model is deployed at. You can edit this as well if you want. So I call the URL, and then I pass in a specific user ID, which we'll see in the UI. This might make more sense too, but there's a user ID in the training data set that contains all those features. This is the amount was $25. Category was grocery at POS, which is the point of sale system. So like in-person grocery. And then this is the latitude and longitude. So that you can use this to be like, how far away from home was this person? Or, right, did they ever make purchases in this area or anything like that? You can do think about being like really far from your normal purchase areas. That's obviously like a signal that could be fraud. So I ran this though, and it says it looks legit. Fraud probability is very, very low here because it's a low amount and it's probably historically what this user's done. We can do this one. Let's see if this triggers a suspicious one. Actually, I said let's trigger one, but I actually didn't test if this did. But we add in the same user, but now the amount is almost $10,000. Category is shopping on the internet. And then this is the latitude and longitude, which is different from this other one. So it might be further away. And we can say that the prediction here is now fraud, and it gives us a fraud probability and some other information, which we'll see in the dashboard here. And then this will deploy the Gradio app. And again, I'll go look at the code here. But you would run this, and this would deploy the other app that we have, which is this fraud dashboard. And this will take a second. So when we look at the code, you'll see that just in that kind of environment area piece that we saw in Flyte, it's very similar for making an app, but you can define replicas and spin downtime. So like you can have a model deployed, and then after 30 minutes of nobody using it, it could spin down. And so you can do that with apps as well. I think the default is like 5 minutes. So this was spun down and then it just spun back up pretty quickly. And then, so let's just run the score. So by default, looking at the user ID 42, the amount 25, this is pretty similar to the ones we just did in the curl. We can see that it thinks this is very low risk of fraud, but it does note that the user is 365 miles from the user's usual area. So that's where that like 0.3 kind of comes in from the model here. And we get other information about the average transaction and stuff like that around the user from the feature store. So let's see if we can make this trigger to fraud here. I don't know exactly how much we have to put into trigger. Let's see if like 420. Oh, that's very high risk. And probably part of that is this hour too. So we adjust to a different hour. We can actually see it goes down quite a bit versus this is like super early in the morning, late at night. That's a very high risk of being fraud. If we go down to what would probably be a more normal hour for them, that greatly decreases. So again, we saw that if we looked at the feature importance for our model, we saw that the amount was a big factor, and then the hour is the second biggest factor for determining if it's fraud or not. And then I see a question in the chat. Let me get to that, and then I can go through the code for kind of the apps that we just did. Someone said they ran into authentication issue, even though I'm signed into Union, although in a separate browser container. If you do want to reset the run, you can always go to runtime and hit disconnect and delete runtime, and that'll reset your whole notebook here, and then you can just run all those code cells again. So you do need to run them in order. Like if you disconnect runtime, you have to run this one again that will make the config. That might fix the issue. Or like I mentioned, if you weren't RCP'd on Luma, you might not have access to the cluster. But if you want to run this locally, you could also, there's a couple different ways. So one, you can set up a Flyte dev box, which you need Docker installed too for that. That gives you a basic local version of this whole UI that we've been seeing. And then it manages your resources through Docker. And you just pip install the requirements. And then you would say Flyte start dev box. And then it'll start up a little local Kubernetes cluster for you and manage your Docker builds that way. But if you don't even want to go that far, and you did just clone this repo down, pip install the requirements.txt. And if you don't want to install Docker or anything like that, you can also just run, sorry, what was the command? Let me pull that real quick. I'll show you something cool that I actually really, really like. Where is my run? So here is the command that we ran to kick it off. But if you want to run this just purely locally, but still get versioning and stuff like that, which is pretty nice, is you can say Flyte run, and then you can say local, and this will run the entire pipeline actually locally without Docker or anything like that installed. But if you want to get a little lightweight version of kind of all the stuff we've been seeing, like saving these reports, getting this run information as it goes, you can say Flyte run local, and then you can say TUI. So this is terminal user interface. You can run this, and then you'll actually get this cool little interface here that does caching stages. So you can see like as this pipeline is running, what it looks like. And again, our model is very lightweight today that even if you don't have an accelerator, you can probably train this XGBoost model. So we can click in though, and then get information kind of like we saw inside of the actual UI. Now, if I pull up even this file, copy this in, even have reports. And this can be all version too. So you can do this purely locally, but you get kind of that version of like hyperparameters and run pieces, which is really cool. And one use case that's really cool for this is if you're building agents at all, it's hard to see, like if you're running agents in parallel or you have more than one going at once, it's really hard to see what's going on with them. So you can actually use the Flyte 2E just locally for local agents and have everything logged there, which is really, really nice. I've done that quite a bit now for agent development. I really like it. So another thing, if you do want to run this locally, you can do it that way. So in the app.py, I'll go through this super quickly. We are seeing which we're defining the features that we want from Feast up above. And then we have this context manager part of Flyte where basically on load, we can pass in what artifacts we want and pull in the specific models and feast features that we have defined. When we get to the actual serving part here, so we're defining our serving environment. It's a fast API environment that we already have kind of pre-built into Flyte. Makes it easy to build fast API things. We are giving it a name, real-time fraud scoring, using feast online features or a description. And we're passing in parameters. So now we pass in the model that we had kind of defined above. We want it to download basically on start time. And then we build a reference this model. And then same with the feast feature store. And then like that config.py for the task, we do the same thing where we define the image that we want this to run in. And then we say what resources we want. Again, we don't need anything crazy for this because pretty lightweight application, even with the feast feature store. We don't need any crazy GPU or anything like that. So we're saying just 2 CPUs, 4 gigabytes memory, and then we give it scaling. We're going to say from 0 to 1. But if you actually had this in production at work or something like that, or even if it's just an internal app for people to use, you might have when I say the min is always 1. So there's always 1 replica with these resources there. You can also define a scaling metric. So if you could say if 5 users come to this, then scale up to another replica. And you could set this replica to a whole, whatever's in your cluster. So you could say 5 or 10 or whatever. And as more users come, it's going to create more replicas. So it can handle the requests coming in. Then you can give it a scale down time. I think by default, it's 5 minutes. Here I'm setting it to 30 minutes. So after 30 minutes of no more requests coming to that model, it'll spin down to 0 in this case and not use any resources. And then I've auth set to false in this use case. So anyone with the URL can access that model, but you can also set this to true, or by default, it's true. So just if other people are logged into your cluster, then you'll be able to access it. So it's really useful for internal apps and stuff like that as well. Just using that authentication part. And then we define our scoring endpoint, which basically just takes in the parameters that we passed it like we saw in curl or through the app, and then gives us a score. And it uses the feast data that's served real time with it too. Oh, and this is pretty important. So a lot of the times you will actually want to have maybe a couple of hard-coded rules. So if you were doing a request, I think someone else is running it now, so that's deploying. So we'll see if this works as that's deploying. So you might have some manual things the model won't be able to pick up on every single type of thing that would probably make this fraud. But you could probably assume maybe that if somebody is spending $9 billion or something like that, that's probably fraud, right? Hopefully it would pick it up that this is a huge standard deviation away from their normal spending habit. But you can have hard-coded rules too, saying well, if it is above a certain amount, just always flag that, right? Or if the distance incredibly far, or again, the amount one is really easy because if the amount is just way above what they normally spend, you should probably just flag that and maybe have that send that text and say are you sure you're actually spending this amount? So you can overwrite the things that the models hopefully do a good job with on those signals, but you might want to have some hard-coded rules in there. And so we actually did that in this case too on our score. And then if we go to the dashboard.py, this is mostly just Gradio code. Gradio is open source library that's run by Hugging Face now, but it gives us access to these nice little UI components. And it's just doing a request like we did in the notebook. That's the curl to the model, but basically just wrapping it around in this Gradio UI that we have here. And there's, if you got to that Gradio UI part, actually, I think I might have authentication false on this right now too. So you can maybe open this up and play around with it potentially. I guess I can double check in incognito if that will work. Yeah. So you should be able to open that and kind of play around with what we built here. And there's a couple examples that you might want to try running, like this, the normal grocery for user 42, late night large spend, see what happens there, right? Is that going to trigger false or potential fraud? I think I saw, it looked like someone was probably doing a run. Yeah, I think someone else is running the code now. Cool. So hopefully that fixed. If that was you, Kevin, I'm not sure if that fixed your issue or if you still have an access problem. And also, if you just install those pip install those requirements. I didn't test this, but should be Flyte start. I might have an existing one, so it might throw an error. But you can type Flyte start dev box. And again, if you have you need Docker installed for this because it will use Docker to like manage your container resources. So you can use that Flyte local 2e run, and that doesn't use Docker or anything. That's just all purely local for you, but it has that kind of nice UI. Or more minimal UI. So it doesn't do like the scaling piece or the building container piece, but it does do that tracking piece and reports, which is really nice for a lot of use cases. Like if you're just doing ML experimentation locally, that can be a pretty cool feature. Flyte start dev box will. Oops, yeah, I don't have Docker running because I turn it off when I'm streaming sometimes because it uses a lot of my memory. I'm getting a new laptop soon with more memory, so I won't start up right now. But if you had Docker running, it would then pull a Docker container down and then give you a local UI, which I actually have one running on a DGX Spark. So this is like the local Flyte UI that you can set up. And then I have runs just like we saw before. But this is all in open source. And then this is all just running on my DGX Spark in this case. But I get all the versioning and artifact management apps as well. So I actually use it on my DGX Spark to host models. And it's kind of nice because I can host this, like I have a Gemma 4 model. I can spin it up directly from this UI. I can also spin it down from the UI, which is nice as well. And then you can set up that scaling a scaling down timer. So I can have it like host a model. And then if it hasn't been used an hour, just go ahead and scale it down. And then I can even just restart it again. So this is on a different computer and I would just SSH into it. And then I have access to all the stuff that you basically just saw, but open source and on one machine, which is kind of cool. Cool. And Kevin said, working for him. Awesome. That was kind of the gist of the workshop today. Hopefully you thought it was interesting. Did anybody learn anything new or see anything that they thought was cool? Also bring up in the docs, if you want to get started, actually bring up run modes, run the dev box. So you can run locally, like I saw or showed with the TUI. If you want to get started with the dev box thing, check out these docs. Again, it's actually very easy and quick to set up. If you have Docker installed, you set up Docker is not that hard either. And then once you have that, you just pip install Flyte and then run that Flyte start dev box, and you'll get something that looks like this. And so it said, thank you. Very interesting. I'm glad you found it interesting. Hopefully, I mean, you said it was interesting, but hopefully it was interesting in a useful way for you as well. And Kevin said, this was great. We'll work on running locally with DevBox. Awesome. And if you have questions, like if you run into any issues with it, again, feel free to join the Slack channel and ask in there. And there's an intro channel in that group too, if you just want to kind of put a little bit about like what you're working on. And it's kind of fun having a more permanent introduction like into the community. With that, I got to wrap up the stream in a couple minutes because I have some other work and meetings I got to go to, but I'm hanging out for like 3 more minutes until like the 1 o'clock mark. So if anyone else does have any questions or comments, let me know. Also, I'll throw it out there. So if you do, oops, so I got rid of the Union tab. If you also want to chat with like an engineer about your use case or anything like that for Union or Flyte, you can book time there. And we have a ton of cool blogs that we're putting out. I just posted this one the other day, actually. So if you are building agents and you're interested in like, what does this look like for agents in LangChain, go check this out. Pretty cool. You can imagine kind of all the, like we saw a pretty small pipeline today. You can imagine running agents in a system like that where you have the scale. Like in this case, it's a research agent, and every single researcher can become its own or research agent that can fan out, which you might have like tens or you could have hundreds of them to go gathering information. That those all can spin up compute and run in their own container and then bring that information back into the workflow. Curious too, are people here working on agents, or is everyone doing more traditional machine learning or deep learning? I feel like everyone I talk to is like toying around with agents in some way, even if that's not like what you're doing fully. All right. I'm going to wrap up the stream. But again, if you have any questions, I'll share one more time. Join the Slack channel. And also, if you want to, you can connect with me on LinkedIn and message me there. But the Slack channel is better because you can post in a public channel and other people can help answer your question as well. So then I'm going to wrap it up. Thank you, everyone, for coming. Awesome to see people in the chat. Kevin, thank you for talking and letting me know that the workflow is running for you. And Pablo, thank you for letting me know. It was interesting. It's always more fun seeing people talk in the chat. So hopefully I'll talk to you all next time.